is Python programming part 5. This is Brian Fagan. I work at Lumpkin County Middle School, which is in northeast Georgia. I'm an engineering and technology teacher that integrates a lot of computer science into his engineering and technology program. And part of that is I like to integrate computer programming using the Python programming language. It's a very easy language to use with middle school students. It's a great language to start with, and it provides a lot of the function that you might want if you have students that are beginners, or if you have students that are more advanced. Python can facilitate that range of learning. So we've been doing a series on activity-based programs, how I like to turn activities in the game or in the classroom, activities and games in the classroom into programs. I feel like it's a better connection for students when they see that the program that they're writing connects to an actual activity. It also helps with the computational thinking part, because they can break down the activity into individual parts and pieces and then program those individual parts and pieces. It's also easier to troubleshoot and fix errors and debug your program when you have it broken down into sections and you understand what each section is intended to do. And when you get an error, then depending on what the error message is or the type of error, you kind of know in what direction you need to go in order to fix the program. So in general, if you're teaching programming, Python's a great place to start, and hopefully this series of webinars has provided you some comfort or encouragement in using programming in your classroom. If you want to go back and get the other parts, they're available on EdWeb. So some resources. This is pretty much 90% of what I use, besides going out and looking for tutorials. I go to the Python website, make sure I have the current version. Right now I think it's 3.6.4. I have a book called Teach Your Kids to Code, which is the foundation for all the programs that I write and activities that I like to build from. The book is great, but all of the codes that I use are available for free. The link there is the code link. The Python standard library also provides lots of resources and information, how to use functions, and introduces you to new functions and provides you examples, really good examples of how to use the functions that you may want to introduce to your students. So I have found that some of my students are comfortable with going to the Python standard library themselves and looking for some of those functions. I don't necessarily provide it as a resource to my students. It can be a little bit dense as far as the information, but if they know what they're looking for, I generally let them try, and then it's a skill that they have to learn. So I give them an opportunity to search the library for themselves. If they cannot find what they're looking for, I will help facilitate that process and show them how to navigate that library. So I think it's good that we give an opportunity to try and learn before we always show them how to do something. So these are some great resources. Obviously, there's plenty more out there. There's plenty of websites that teach Python programming. A great one, Solo Learn, is a great website for learning different languages. It provides great examples. It provides content, questions, and coding all on one website. So I've used it in the past when I was teaching some 8th graders a little bit of Java. They felt that it helped them learn. So I've aligned this presentation, this webinar, to the CSTA standards. Some of these have been overlapping, so if you go back and listen to some of the other webinars, you'll see that some of these standards have been already used, but we will be creating programs that use variables, store, modify data. We're going to clearly name variables. We're going to debug and fix errors if we have any. We're going to try to use correct terminology and describe the steps that we're using and choosing. We're also, these last webinars has focused a lot on control. Part 4 was looking at simple loops. In part 5, this webinar is going to look at conditions and conditionals. So we're going to create programs that include conditionals, and we're going to design and iteratively develop programs that combine control structures, including nested loops and compound conditionals. So those are going to be a part of this course today. One of the key things is to understand that conditionals are a part of the programming language, and depending on the conditions that are set, a conditional hash will test to true or false. So depending on when a condition tests to be true, then those commands that are in that condition will execute. If that condition tests to be false, then other conditions or other statements, commands will occur. It's very similar to if you clean your room, you can go to the mall. Else, meaning that you did not clean your room, you cannot go to the mall. So those are conditionals. If one event tests to be true, then this is what is going to happen. If this condition tests to be false, then this is what is going to happen. And that can be as simple as just one condition. If you clean your room, you can go to the mall. But you can also have multiple conditions using and ors. If you clean your room and you mow the grass, then you can go to the mall. So both of those conditions have to test to be true in order for you to go to the mall. If either one of those conditions tests to be false, the whole condition is false and you can't go to the mall. They are together if you're using the and operator. You can also use or. If you clean your room or you mow the grass, then you can use the car and go to the mall. In that case, you have an option. You can choose either cleaning your room or mowing the grass. And since the or condition was used, if either of those tests to be true, then you can go to the mall. Then whatever commands follow that condition will execute. If either of those tests to be false, then again, you're stuck at home watching reruns of the Golden Girls or something. I don't know. So conditions in programming provide those possibilities. They will have to test to be true or false, and there will have to be what happens when the condition tests to be true or false. So we're going to look at two programs today, What's My Grade and What to Wear. They are both available for download. You can just copy and paste them right out of my drive. You can just copy and paste this right here into your own Python program page, save it, and execute the program, and then you can make changes. So we have What's My Grade and What to Wear. One of the activities I do prior to teaching conditionals is we actually play a game of red light, green light. So we go out in the football field. I separate myself from the students by about 45, 50 yards. I have them all lined up shoulder to shoulder, and I present them with a series of conditions test true. Then they get to execute whatever the commands are that go with that condition. So for example, if you are wearing a red shirt and wearing white shoes, you can take one step forward. Else, if you are wearing a red shirt and wearing sandals, take 2 steps forward. Else, if you are wearing a red shirt and wearing blue shoes, take 3 steps forward. So it helps them to start thinking about conditions, and when conditions test to be true, what commands are executed as a result. And I only put one example here, but there are multiple stages of that. You can do if and ors. If you are wearing a red shirt or wearing white shoes, do this. You can do a series of ifs and a final else if you just want to use one condition. If you're wearing a red shirt, else if you are wearing a blue shirt, else if you are wearing a green shirt, and then else if none of those conditions are met, just else just stand still and don't move at all. So it's a great game, red light, green light. They already understand the basic rules about moving closer to the person who is speaking. And so you can provide any series of conditions. And it probably helps to go ahead and type those conditions out beforehand, kind of have them on cards. That way it's more random and they don't feel like you're picking certain kids because they're wearing red shirts or whatever. Just have all those conditions typed up. You can laminate them, or the library can laminate them. You can go outside and help them understand that conditions must test to be true or false. And when they test to be true or false, what commands are executed in the program. So it's a great visual, kinesthetic activity that you can use to teach conditionals. What we're going to learn to do today is we're going to use if statements to make decisions using conditionals. We'll use conditionals and Boolean expressions to control program flow. We'll write conditional expressions using comparison operators: less than, greater than, is equal to, not equal to, less than and equal to, and greater than and equal to. That is not the smiley face. Use if-else statement combinations to choose between two alternative program paths. Write an if, else if, else statements that select from a number of options, and use the and or to test multiple conditions at once. So that's our goal for today. Again, if you ever have any questions, you can always email me, brian.fagan@lumpkinschools.com. You can always just reach out, and I'll be glad to help you with computer science and programming in your classroom. So let's go ahead and look at the two programs. We're going to start with, what's my grade? So this is a pretty straightforward program, and it's one that the students understand because they already know sort of the grade structure, that if you have a 90 or above, you have an A, and if you have an 80 or above, you have a B, assuming it's less than a 90. A 70 or above a 70 but less than an 80, you have a C. And if your grade is equal to a 60 or above a 60 but less than a 70, you have a D. And then everything else is an F. So everything less than, actually I think in most schools anything less than a 70 is probably an F. So we could actually probably get rid of this conditional right here. But this might be more of the university format for grading. They give you an extra chance to get a D there. So, but the first thing that we're going to prompt is we have a variable called grade. So we're using a very clearly defined variable. We know that variable grade is going to be equal to some value, some grade value. And we're going to prompt the user to type in an input. Enter your number grade 0 to 100. So that is going to be the prompt that comes up. They can respond to that prompt any way that they want to. We're not writing a complex program that's going to ensure that they are using a number, but we're going to hope that they respond to the prompt correctly. They're going to type some number grade between 0 and 100. And then it's going to, the variable grade is going to be used in our series of conditions. So we're going to start at the top, because if their grade is greater than a 90, then they have a 100, and we don't need to consider any of the other conditions. So our very first condition here is if grade, which is the variable that we're using, and it will be equal to the user's input, hopefully a numerical value between 0 and 100. If it is greater than or equal to, that's what this reads, if grade is greater than or equal to 90, then print to the screen, you got an A. You could increase the number of conditions if you want to have A pluses or A minuses. Right now we're just leaving it as if the grade is greater than or equal to 90, then you have an A. So the condition is greater than or equal to. If that condition tests to be true, then it's going to print this statement. If this condition tests to be false, then it's going to move down to the next condition. This is our else if. If it's not greater than or equal to a 90, it may be, or else if, we're going to check the next condition. So these conditions are going to occur in order. So if this condition is not true, if this tests to be false, we're going to move down to the next condition. If grade is greater than or equal to 80, we're going to print that you got a B. Now, you may think, well, if it's greater than or equal to an 80, it could also be greater than 90 and test to be an A. And that's true, except for we're moving through these conditions. So we've already tested it to be false up here. We've already with our conditions, we know the grade is not greater than 90. So it's not going to be an A. So even though this condition only states greater than or equal to 80, since the first one is false, this will test true and print that you have a B. So we know the user has a B and not an A here because this first one tested false. If you did not have this first condition, then we wouldn't be positive that they had an A or a B, and we would have to be you've earned an A or a B. So this reads just above an 80, but since this condition tested to be false, if this one tests to be true, they have a B. If it tests to be false, it's going to move down to the next condition, greater than or equal to 70, they'll have a C. If this tests to be false, it's going to check to see if their grade is greater than or equal to a 60, meaning they would have a D. And if none of these conditions test to be true, then our final condition is going to automatically execute. It's sort of a default condition. This else condition just prints you have an F. So we don't really care below a 60 if they have a 50 or a 40 or a 30 or 20. We're just saying if any of these conditions test to be false, if all of these conditions test to be false, then you have an F. So we're going to run that real quick. Bring this over here. So enter a number of grade between 0 and 100. I'm going to start with the first one. So we got an A. I'm going to run it again. We got an 80. Let's just be creative. We got an 85. So we got a B. We're going to run it again and say a 72. Should have a C. We're going to run it down here towards some of my grades in school with the 61. You got a D. And now we're just going to choose any number less than 60, a 10, and it's guaranteed to be an F. So in each one of these cases, you can see how it moves through the conditions in order to determine the letter grade. Since this one was a 72, it was not greater than or equal to 90. It was not greater than or equal to 80. It was greater than 70, so you got a C. And it prints that you got a C. So this is just a very easy if else condition. We use this same program with the rock, paper, scissors program with combining some other conditions with it. So it's actually a really good program. It's a good one to start the kids with. So let's move this one away. All right, our next program is a what to where program. And it uses the if, else, if conditions, but it combines it with more operators and the and condition. So now we have to have two conditions to be true in order to execute our commands. So the very first part, or the two things that we're checking for, is if it's raining outside and if it's cold outside. And the possible combinations are no, 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 yes, yes, no, and yes, yes. So there's a combination now of conditions that are true, and you might have different outcomes. If it's cold outside but it's not raining, you might want to wear a jacket but not carry an umbrella. If it's raining outside and it's not cold, you probably carry an umbrella but don't carry a jacket. If it's raining and cold, you carry an umbrella and a jacket. So there's lots of different conditions there that can come true. So what we're doing here is, since we're using yes and no responses, so we still have our variables, rainy and cold, and they're named appropriately. It's very easy to understand what they're for. They're also equal to an input, meaning that the user, the end user, the person at the screen or at the keyboard is going to have to put in some input. Since we're using yes, no conditions, we're going to use the Y and the N to represent yes and no. And since that Y and that N are going to be used in our program, we want to make sure that they match. A capital Y and a lowercase y don't match when it comes to checking for conditions. So we want to take this user's input and make it lowercase. So if they put a capital Y in, it automatically makes it a lower y. If they put a capital N in, it automatically makes it a lowercase n. That way we can use it for matching later with our conditions. So we're going to do that with the how's the weather, is it raining, and then is it cold outside, yes or no. Both of those become lowercase. So we get to our first condition, if rainy is equal to, that means is equal to yes, and cold is equal to yes, then you better wear a raincoat, and maybe you could type in here and carry an umbrella. So if it's rainy and cold, I'm going to say and umbrella. All right, so you wear a raincoat because it's a raincoat, but you know, you may not want to necessarily get wet, so let's carry an umbrella just in case it's a lot of rain. So the next is if either of these conditions tests to be false, then we need to move down to the next condition, because this is an and. So this is you have to clean your room and mow the grass if you want to go to the mall. It has to be and it's cold to wear and break. Either of those conditions are false, then it's down at check condition. Is rainy outside? Yes. And cold? Yes. Looks like some in here. Carry umbrella with you. Change that to no. So umbrella with you. If it's rain, warm, necessary. Need the. So again, either of those conditions test false. Any of the response don't match responses. Jumps down. Next one. So we're going to turn on to, it's not rain outside, but it's cold. We don't umbrella the jacket. So it's not you. I don't know. That's what. Let's take it in the not you. So could change if is equal to no, but right now using is not equal to yes. So either side line. So equal to assumed it equal to no, it's equal to. So if it's equal to yes, it's no, and is equal to then conditions here. So essentially what this is take both of these responses and running through the conditions, and both conditions are true, in that condition that it prints out. Real quick. Here so you can. How's the weather? Raining. It's raining outside. It's outside. Cold outside. So we put on a jacket. Outside. We don't need enough. It's not raining. So what's right? Is it raining? Yes. Cold outside. Better wear a coat and umbrellas. Conditions are. We're going to those items. Again, is outside no, outside no. Where you want is outside. I would go with the whatever you want. You should wear that definitely match warm weather and it's raining. And then last one is it raining outside? Yes. Is it cold outside? No. Just carry it with you. Checks based off of responses, and in this case, conditions to test in order to get the print. And you can make these and or as we changed it to any old. You could have a variety of conditions and to test in order to command. Conditions are fun because you start to integrate them into things. simple programs like what to work. You can simple programs like the web page, but you can also start building game and for game as the character this item inventory that item, so the next into this count is the character hit point or their level greater than or equal level. So do this, they can't this, or else something else. So it begins to provide a lot of options and tier options. So you can have variety of movement in a game. Additionals are foundational ventures, have to respond and have to things to bring into different areas. They're used quite, and it's a great place to learn how to use simple pro Python. Back and you that these that we did use statements, did use conditions to program which direction the program went. We comparison is less than is equal. Use the statement between paths. The if elements. I just have options default if test to be going to default else, and we look and we could have that and or the test of different. These programs available on my. You can download them on the link. Always available for questions, and these just found for a program. It's always best way to do this is click on one of the programs, copy, paste it into Python program, change table name, condition, practice with condition, follow the. If you feel comfortable just following up, just in your own if greater than 50, and your own can. That's the practice. You fix it. That's how you better program. So it's one of those things that you have to practice and get with. So part 5 conditions, and look forward to working on 6 and doing it soon. If you have questions, you can reach out. I'm at Lumpkin School. You can either email brian.at.lumpkin.com, or you can go on the page, you can kind of page and reach. So, all right.